Properties of real numbers. Why do we learn the properties of real numbers? The properties help us to solve equations and evaluate expressions. They help us to explain or justify our solutions. They tell us why we are able to do different things. The first property is a commutative property. The commutative property tells us that when adding and multiplying, the position of values does not change the answer. When we're talking about addition, this means that when a and b are any real numbers, a plus b is the same as b plus a. So if we have a calculation to do, 3 plus 10, the commutative property tells us that 3 plus 10 is the same as 10 plus 3. We can swap the 10 and the 3, the position, and we'll still get the same answer. Both sides are equal to 13. With multiplication, it's the same thing. When a and b are any real numbers, a times b is equal to b times a. So 2 times 4 is the same as 4 times 2. They both give us 8. Next is the associative property. The associative property tells us that grouping symbols can change positions without changing answers when we are adding and multiplying. So let's look at when we're adding. When a, b, and c are any real numbers, a plus b plus c is the same as a plus b plus c. We can change where we have the parentheses, the grouping symbols, and we'll still get the same answer. So if we look at it with actual real numbers, we have 4 plus 7 plus 2. So the grouping is the 7 plus 2. The associative property tells us that if we group the 4 and the 7 instead of the 7 and the 2, we'll have the same answer. So on the left side, it turns out to be 4 plus 9. The right side turns out to be 11 plus 2. Both sides tell us the answer is 13. We can take this one a step further if we wanted to, and we could group the 4 and the 2 together and have the 7 separate, and we would get the same answer too. 4 plus 2 would give us 6, 6 plus 7 would give us 13. The order of the values when you're adding do not matter. When we're talking about multiplication, we have the same thing. When a, b, and c are any real numbers, we can change the grouping and we'll have the same answer. So for the left side, we have the grouping of b and c. On the right side of the equal sign, we have the grouping b around a and b. So when we look at actual real numbers, we have 2 on the outside times 4 times 8 with 4 times 8 on the inside. That's going to be the same as if we have the grouping symbols around the 2 and the 4 and the 8 on the outside. So we're going to have 2 times 32 on the left. We're going to have 8 times 8 on the right side. The answer is going to be 64 for both sides. Again, we can do the grouping symbols around the outside values and have the inside value, the 4, be on the outside, not inside the parentheses. We can do 8 times 2, which would give us 16. 16 times 4 is still going to give us 64. The order of the values do not matter when you are multiplying like this. That's what the associative property tells us. Next, we have the identity property of addition. This property tells us that a number maintains its identity when added to 0. This is the reason we can take any value, add it to 0, and have the answer be that value. A plus 0 is going to equal a every single time. 12 plus 0 is going to equal 12. The identity property is a justification for this calculation. The inverse property of addition is a little bit different. It tells us that the sum of a number and its opposite is 0. So a plus the negative value of a is going to give us 0. 8 plus negative 8 equals 0. Multiplication also has an identity property. The identity property of multiplication says when a number is multiplied by 1, the product is that number. So when we have a value a times 1, the product is always going to be that number, a. So we're looking at real numbers down here on the bottom. Our real number here is 7. 7 times 1, our answer is going to be 7. The identity property is a justification for doing this calculation. We also have an inverse property of multiplication. That tells us that when a number is multiplied by its reciprocal, the product is 1. Now what is a reciprocal? To find the reciprocal of a number, we're going to write that number as a fraction, and then we're going to switch the numerator and denominator. So if we have 6 and we're going to write 6 as a fraction, we're going to write it 6 over 1. To find the reciprocal of 6, we're going to flip those values. So we're going to have 1 over 6 instead of 6 over 1. The reciprocal of 6 is 1/6. So going back to this property, when a number is multiplied by its reciprocal, the product is 1. A times 1 over a is going to give us a over a, which is equal to 1. Looking at actual values, 5 times the reciprocal, which is 1 over 5, would give us 5 over 5, which is equal to 1. The inverse property of multiplication tells us our product's going to be 1 when we multiply a number by its reciprocal. Next we have the zero product property. This tells us that if a times b is equal to 0, a, b, or both a and b must be equal to 0. So if we have 4 times an unknown value equals 0, that unknown value must be 0. Going on to the distributive property tells us that multiplication distributes across addition. So for the distributive property down here, we have a times the sum of b plus c is equal to the product of a and b plus the product of a and c. Looking at it with actual values, if we have 3 on the outside, 3 times the sum of 7 plus 1 is equal to 3 times 7, the product of 3 and 7, plus 3 times 1, the product of 3 and 1. 3 times 8 would give us 24. 21 plus 3 would give us 24. We can do this because of the distributive property.